Welcome to this explainer. Today, we're diving straight into one of the most fascinating and honestly genuinely perilous medical mysteries of our time. You know, every so often, a substance comes along that just flat out refuses to fit into our neat little medical categories. It's not your classic psychedelic, it's definitely not a sedative, and it is certainly not a stimulant. Yet it carries this decades-old reputation for doing something that no other medicine is supposed to be able to do. We're talking about Ibogaine, and today we're going to unpack the honest, hard neuroscience behind what scientists are calling the reset.
Just imagine for a second being able to switch off the absolute agony of opioid withdrawal. And I mean in a single day. For someone deeply in the grip of a severe heroin or fentanyl addiction, withdrawal usually means enduring days of intense sweating, severe cramps, and this bone-deep sickness, which is often just slowly managed with substitute drugs. But with a single overnight session of Ibogaine, patients consistently report that their severe withdrawal symptoms are essentially just switched off. And even more importantly, the intense cravings that constantly drive relapse are quieted. It completely turns our modern understanding of addiction treatment upside down. But, of course, that brings us to the ultimate paradox here, and I need to make a really important disclaimer right up front. How does a single root carry this miraculous promise, yet also carry a sudden lethal risk? I want to state very clearly right now, this explainer is strictly educational. This is absolutely not medical advice. Ibogaine is one of the very few substances in this field that can literally kill you outright if it's used carelessly. So we're going to explore both the profound healing potential and the very real biological peril that rides right alongside it.
Okay, let's dive right into this. Section 1. The addiction interruption. To really grasp what this molecule is all about, we first have to look at where it comes from. It starts with the Tabernanthe iboga shrub from the forests of Central Africa, which produces a bitter root bar containing our molecule of interest. Centuries ago, and actually still today, it's been used in the Bwiti spiritual traditions of Gabon. In small doses, indigenous peoples would use it as a stimulant for endurance during hunting, and in massive ceremonial doses, it served as a powerful rite of passage to commune with ancestors. The Western medical story? Well, that doesn't even begin until 1962. But fast forward past decades of this being entirely on the fringes of medicine, and we suddenly arrive at massive modern milestones, a landmark Stanford clinical trial in 2024, and a staggering $50 million in research funding from the state of Texas in 2025.
So what exactly happened back in 1962? Well, there was this young American named Howard Lotsof. He was dependent on heroin at the time, and he ingested Ibogaine expecting, a typical psychedelic trip. But when the experience wore off, he made a totally startling discovery. His physical withdrawal symptoms and his deep craving for heroin, they had simply vanished overnight. He called it an addiction interruption, and it was this single, strange, highly reproducible observation that kept the Ibogaine molecule alive in underground clinics out at the very edges of medicine for the next 60 years.
Which brings us to Section 2, a pharmacological dirty drug. In modern pharmacology, we usually design medicines to hit exactly one target cleanly, right? We do that to avoid side effects. Well, Ibogaine does the exact opposite. Scientists actually call it a dirty drug because it touches almost everything all at once. It antagonizes NMDA receptors, affecting neuroplasticity. It interacts with kappa and mu opioid receptors, which impacts pain and addiction pathways. It binds to sigma-2 receptors, blocks the alpha-3 beta-4 nicotinic receptors to regulate cravings, and alters serotonin transport for mood and perception. It's like a biological shotgun blast. It deliberately overwhelms the brain's systems simultaneously. But this multi-target approach is exactly what makes its effects so incredibly unusual. But here's the thing, the acute drug experience is really only half the story. As soon as Ibogaine enters your body, your liver rapidly starts converting it into a metabolite called noribogaine. Now, unlike the primary drug, noribogaine lingers in your system for days, maintaining its very own unique receptor profile. Researchers actually believe this long, quiet biological tail is the secret behind that prolonged anti-craving effect. It perfectly explains why the freedom from addiction can heavily outlast the initial 24-hour experience by weeks or even months.
Let's move on to Section 3, resetting the reward circuit.
So how does overwhelming all of these receptors actually cure a craving? How do we go from a dirty drug to completely resetting an addicted brain? Well, the neuroscience points to a powerful three-step reset that perfectly merges biology with deep psychology. First up, Ibogaine triggers a massive surge of a growth signal called GDNF, right in the ventral tegmental area. That's the absolute core of the brain's dopamine reward circuit, and this surge actually feeds back to reduce drug-seeking behavior. Second, it blocks those alpha-3 beta-4 nicotinic receptors we mentioned, which is directly linked to stopping the self-administration of opioids, stimulants, and alcohol. And third, layered right on top of this physical rewiring is a profound 24 to 36 hour psychological event. Because of this intense psychological effect, Ibogaine is classified as an oneirogen, literally a dream generator. While high-dose psychedelics often feel very outward, exploding, and deeply abstract, users describe Ibogaine as turning inward and getting cinematic. It basically produces a waking dream. We're talking a vivid, panoramic replay of a person's formative memories, their traumas, and their life choices. Patients truly feel like they are confronting the very roots of their addiction. And for those who go through it, this intense psychological life review feels entirely inseparable from the biological medicine.
All right, that brings us to Section 4, the evidence today. For decades, the story of Ibogaine lived entirely on anecdotes coming out of unregulated clinics in places like Mexico or Costa Rica. But we are finally moving away from just theoretical mechanisms and getting into rigorous modern clinical data. In 2024, Stanford published a massive landmark study in the journal Nature Medicine. They followed 30 special operations military veterans suffering from traumatic brain injury and severe trauma. After receiving Ibogaine, which was carefully administered alongside intravenous magnesium to protect their hearts, the researchers reported an astounding 88% reduction in PTSD symptoms. 88%, and that came alongside major, highly durable drops in depression and anxiety that persisted long after the actual treatment.
And believe me, the scientific establishment is absolutely taking notice of this data. In 2025, the state of Texas committed $50 million to a massive Ibogaine clinical trial program. This is a huge deal. It represents the biggest government-funded Ibogaine research effort in the world. After more than 60 years of living on the absolute fringe of medical science, rigorous trials and massive institutional funding are finally validating the promise of the Ibogaine reset.
But we have to talk about Section 5, the lethal cardiac risk.
I need to deliberately shift the tone here for a minute, because we absolutely must address the other side of this coin. The biological reality is stark. Ibogaine is genuinely dangerous, and it can kill you. The exact same molecule that rewires the brain's addiction center unfortunately also blocks the hERG potassium channel in your heart muscle. And when this happens, it prolongs what cardiologists call the QT interval. That's the electrical recovery phase of your heartbeat. If that interval gets too long, it can trigger a condition called torsades de pointes. That is a chaotic, deadly arrhythmia. This isn't just theoretical, folks. Tragic deaths have absolutely occurred.
This stark contrast is exactly why the setting is a literal matter of life and death. In a monitored medical trial, like that Stanford study, patients undergo continuous cardiac screening, strict monitoring, and crucially, they are given intravenous magnesium to blunt that dangerous QT effect on the heart. It's a highly calculated, carefully managed medical risk. But in an unregulated clinic, you've got unscreened patients who might have unknown heart conditions, electrolyte imbalances, or even other drugs still in their system. Taking Ibogaine in that Wild West setting is quite literally a deadly game of chance with your heart.
Which leaves us with this final, truly profound question for the future of medicine. Can science engineer this addiction reset while leaving the cardiac danger behind? Because Ibogaine's remarkable healing benefits and its lethal cardiac risks actually seem to stem from entirely different parts of the molecule's interaction with the body, chemists are already designing experimental analogs, like tabernanthalog, that attempt to keep the neuroplasticity and the anti-craving effects while entirely shedding the heart risk and that intense 36-hour trip. It leaves us to wonder, could this incredibly dangerous, ancient natural molecule be the exact blueprint that inspires tomorrow's safest, most revolutionary addiction medicines? That is definitely something to think about. That's all for this explainer. Thanks for joining me, and stay curious.